So let's look at the homework. You are supposed to do questions 10 onwards from exercise 12b. And what we'll be doing today is go over the questions very quickly, watch the video, and if you have any questions, then we can discuss them in our next class. Question 10, where AB is a chord of a circle. You need to realize that this is a sort of very common question, we need to realize that the triangle AOB is an isosceles triangle because OA and OB are both radii of the circle. Therefore, we have an isosceles triangle, which is AOB. And it's very important to remember that a property of the isosceles triangle is that the perpendicular from the vertex of this isosceles triangle to the base bisects the base and the vertex. So if you draw a perpendicular like so, this bisects the base and bisects the angle. So those two are equal. Those two angles are equal. And in this case, the radius is 5, so OA is 5, and AB is 8, so this part, let's say from A to D, is half of AB, so it's 4, and you can calculate this angle AOD. The 4 is the opposite, the 5 is the adjacent, so the angle AOB is equal to sine inverse of the opposite over the hypotenuse. You need to find the angle, and then you must multiply by 2 because the angle AOB, sorry, this is not AOB, this is AOD. The angle AOB is twice the angle AOD. Here we have a right angle triangle ABC, and we have an angle bisector at A that meets BC in X. The question is X the midpoint of BC? And the answer is no, certainly not. Because this can only happen if the triangle was isosceles based on the previous theorems that I had just presented. AC is not the same length as AB, so the bisector of the angle is not the bisector of the base BC. So what's the distance between X and the midpoint? First of all, in order to know this distance, we need to know the length of BC. And this can be done by Pythagoras. So BC is the square root of 8 squared minus 5 squared, and that equals 7. So that's the first piece of information. Now the next thing is to work out how far is X from B. The first thing to do is say, okay, let's calculate the angle, for example, BAC. As far as BAC is concerned, in the big triangle, the 5 is the adjacent, and the 8 is the hypotenuse. So the angle BAC is equal to cosine inverse of the adjacent over the hypotenuse. And let's calculate that. And that's 51.3. The three significant figures. So in this case, half of this angle, because BAC AC is bisected, let's consider BAX is half of the 51.3. Just to maintain accuracy, why not divide this by 2? Because there's no rounding, so we can say that it's 25.7. You see, I did not use the 51.3 to maintain accuracy, and this gives me 25.7 degrees. So the task is now to calculate the distance bx. So I want to consider this triangle, and I have just calculated that this angle is 25.7 degrees. Let me call this length L. As far as the 25.7 degrees is concerned, L is the opposite and 5 is the adjacent. So tan 25.7 is equal to L over 5. Therefore, L is equal to 5 tan 25.7. And I still have the exact value of the angle on my calculator, so I can say that I want to calculate 5 times tan of the answer, thus maintaining accuracy. And this gives me 2.4 centimeters. But the midpoint of BC is, let's say, somewhere here. Let's call it D. And if we draw the line here, if this is B and this is C, then D is somewhere here, and X is somewhere here. This distance we calculated as 2.4 centimeters, and this distance is obviously half of the 7, so it's 3.5 centimeters. Therefore, the distance between X and the midpoint is simply 3.5 minus 2.4, and this gives us 1.1 centimeters. Again, the principle here is that the perpendicular bisects the base because it's an isosceles triangle. And don't worry about the axes. We have this length now is x over 2, and I want to calculate the base angles. I have the adjacent and the hypotenuse, so that's cosine. So theta is cosine inverse of the adjacent divided by the hypotenuse, which is 2x over 3. You do the work and you'll find out that the x's cancel out, and you can work out the value. In this case, we have two triangles, and let's say that we have a triangle with angles of 24. Here is 24 and the base is 28 centimeters, and we want to find these new base angles if we have the same base like so, but with triple the area, that's 3 times the area. So we are comparing two triangles. Let's put the information that we have. This is 24 and this is 24 degrees. The base is 28 centimeters. Here, the base is also 28 centimeters. We don't know the angle theta. But I know that the height is different. This is h, and this is, let's call it L. What is the relationship between L and h? Since the base is the same, we have the rule for the area of the triangle. The area equals half the base times the height. Now, the base is the same in both triangles. The half is the same in both triangles. So if the area of the second triangle is 3 times the area of the first triangle, then its height must be 3 times the height of the first one, because the half and the b are the same for both. So we can improve our work and say that this is 3h. Can we calculate h from this triangle? Of course we can. Remember, this is an isosceles triangle. H, as far as the 24 is concerned, is the opposite, and this side is 14 because the perpendicular bisects the base. So tan 24 equals h over 14, and you can work out h as 14 tan 24, calculate the value, and then calculate the height. So 14 tan 24, we have calculated h, but the height of the bigger triangle is 3 times the height, so times 3, and this equals 18.7. So this height is 18.7. And again, tan theta in the big triangle is equal to the opposite, 18.7, divided by the adjacent, which is half of the base, which is 14. So theta equals tan inverse 18.7 over 14, and this is something that you can calculate. Now, the angle of elevation from a marker on level ground, so we have horizontal ground, to the top of a building 100 meters high. So this is the building, and it's 100 meters high. Is 22. So the angle of elevation is 22 degrees. Let's say that's where the marker is. It's right here. So we want to find the distance from the marker to the base of the building, and obviously it's the case for the tan. So tan 22 is equal to 100, and let's call it x. This gives us x is equal to 100 divided by tan 22, and that's 247.5 to 1 decimal place. Yes. Now, we're going to move the marker towards the building, so the angle of elevation becomes 40. So we're going to place it somewhere here, so that this angle is 40 degrees. Now let's call this distance, let's call it y. And taking the smaller triangle, tan 40 is equal to 100 divided by y. This gives us y is equal to 100 over tan 40, which is approximately equal to 119.2 meters. So this means that if this entire length is 247.5 and if this distance is 119.2, simply subtract 247.5 minus 119.2 and you get your final answer, which will be the distance by which you have to move this marker. So here we have an observer, obviously standing on flat earth. Let's say he's here. Notices a plane flying directly overhead. So that means that we have a perpendicular here because it's directly overhead. 2 minutes later, it's an angle of elevation of 27. So 2 minutes later, the angle of elevation is 27. Assuming that the aeroplane is traveling with constant speed and altitude, i.e. it will continue the same straight line, find the angle of elevation after another 2 minutes. So we want to find this angle. Now if the plane is traveling at constant speed, it will travel this distance in 2 minutes, and in another 2 minutes it will travel an equal distance. So it seems that we have little information. So if we call this distance x, then this distance is also x. And because the plane is flying overhead and at the same altitude, then its path is parallel to the ground. So what we have is this angle is 27. And this is the angle that we want to find, theta. So we also have a right angle here. So if we assume that the height is y, then from this small triangle we have y over x equals tan 27. And from the bigger triangle we have y over 2x equals tan theta. So this is equation 1 and this is equation 2. Thing is, we might feel that we have 2 equations and 3 unknowns, and that is a little bit confusing. How can we solve that? But a nice remark would be to say, okay, we have y over x on the left hand side of the first equation here, and we have something that is somewhat similar. So why not multiply this equation 2 by 2? Both sides, multiply them by 2. So equation 2 becomes, if we multiply both sides by 2, we get y over x equals 2 tan theta. So this is the new version of equation 2. And if you remark, we have y over x here equals something, and y over x equals something else. So obviously those two sides must be equal. As I say in class, y over x equals balalam, y over x equals balalu, therefore balalam equals balalu. And we can set up a new equation. 2 tan theta is equal to tan 27. Thus, tan theta equals tan 27 over 2. All over 2. It's not half of the 27. You find the tan first and then you will divide by 2. So let's do that on the calculator. The way to do this properly is to calculate tan 27 divided by 2, and you get a value for tan theta. So theta, we don't need to write this down. Theta equals the inverse tan of this. So shift tan of the answer, and this is 14.3 degrees. So theta equals, I need to stress that another way of finding it is to say, okay, here is tan 27. We need to divide it by 2. This is the 0.254. This is tan theta. And then to go from tan theta to theta, shift tan of the answer. And here you have your 14.3 degrees. Now, an even more interesting question. A surveyor is watching a volcano. So here is the volcano. And here is the lava. The angle of elevation is 23. So this is 23 degrees. The surveyor moves 750 meters closer so this is 750 meters, and the angle of elevation is now 37. What is the height of the volcano? Obviously, this is a technique that we need to utilize when we cannot actually measure the height of the volcano. So, what we can do is label things. I have h here, and let me say that this distance is x. So I have two triangles. The first one, if I separate them, the first one is this, and the second one, the bigger one, is h, and this is 23 degrees, but the base is 750 plus x, and both are right angles. And here we have two variables, which means that we need two equations. From the first triangle, the smaller one, h over x equals tan 37. And from the other triangle, h over x plus 70, or plus 750, or 750 plus x if you want, doesn't matter, equals tan 23. So how do we solve these simultaneous equations? What we can do is make life easier for us and calculate the value of the tan. And let's say we will round it to 4 significant figures, just to maintain accuracy. H is equal to x times tan 73. What's tan 37? What's tan 37? Tan 37 is equal to 0.7536. 0.7536. This is tan 37 times x. So this is equation 1, and that's how it becomes after multiplying both sides by x and evaluating tan 37. The next one, equation 2, becomes h is equal to tan 23 multiplied by x plus 750. So let's work out what tan 23 is. And to 4 decimal places, we have 0.4245 times, inside brackets, x plus 750. And obviously h equals something from the first equation, and h equals something else from the second equation, so those two must be equal. And you don't have to use h, you will end up with a linear equation in x. You can solve that, substitute in equation 1 or 2, but 1 is easier, to find the value of h. And that's it. You do that on your own. For question 17, we need to find the shortest distance between the two parallel lines. First of all, let's remember that the shortest distance is the perpendicular distance. The distance between a point and a line, or between two lines, the shortest distance is defined as the perpendicular distance. And we want to do that using trigonometry first. So what you can do is say, okay, what I have is a perpendicular distance like so, and that's the distance that I want to find out. I need a triangle, and I have one right here. And it's obvious that this distance from here to here is 2 units, because the distance between 4 and 2 is simply found by subtraction. Now I need an angle in order to calculate this distance d. What I can do is, okay, I can calculate this angle right here from the big triangle here. In this big triangle, this distance is 6, and this distance is 4. And if this angle here is theta, then this is the opposite, and this is the adjacent. So it's the tan. So tan theta is equal to 6 over 4. Therefore, theta equals inverse tan of 6 over 4, giving us 56.3 degrees. So let me go back to the smaller triangle and let me sketch it out more clearly here. This is the 2. This is the distance that I want to find out, and this is the angle of 56.3. As far as this angle is concerned, the side D is the opposite, side 2 is the hypotenuse, so we're talking about tan, so sine 56.3, sorry, we're talking about the sine. Sine 56.3 is the opposite over the hypotenuse, which is the 2. So D equals sine 56.3 times 2, and this equals 1.66 centimeters. Now this is based on trigonometry. If we want to do it using areas, then we can consider the big triangle, and we want to calculate its area. This distance is 6, and this distance, which is the height because this is a right angle, is 4. So the area 1 is equal to half the base times the height, and this equals 12 square centimeters. And then if we look at the second triangle, this distance is 3 and this distance is 2, so we have the area 2 is equal to half times 3 times 2, which is 3 centimeters squared. Now, consider the heights. Let's drop a perpendicular from here all the way down to here. For the small triangle, this is the height, and for the bigger triangle, this is the height. So the difference in the two heights is the distance between the two parallel lines. So since we have the areas, and we can consider those to be the bases, and we can calculate the heights. So let's do that. This point is 0, 4, and this point is 6, 0. What is the distance between these 2 points? Using the rule that we learned in straight lines, it's L1, or let's call it base 1. This is base 1, is the square root of 6 minus 0 squared plus 0 minus 4 squared. And this is 36 plus 16, so it's root 52 centimeters. Similarly, this point is 3, 0, and this point is 0, 2. Let's call this base 2. So base 2 is equal to the square root of 3 minus 0 squared plus 0 minus 2 squared and this equals root 13 centimeters. Of course, you could have done this by Pythagoras. You could have said 6 squared plus 4 squared equals b1 squared, and 3 squared plus 2 squared equals b2 squared. So a1 is equal to half b1, which is root 52, times the height, h1, which is equal to 12. And similarly, a2 is equal to half root 13 times h2, which is 3. Thus, you can calculate h1 is equal to, by cross multiplication and dividing by root 52, it's 24 divided by root 52, and h2 is equal to 6 divided by root 13. And the distance between the two lines is simply the difference of those two heights. So what you want to be calculating is 24 over root 52 minus 6 over root 13. And let's do that. 24 divided by root 52 minus 6 divided by root 13, and this equals 1.664. But to three significant figures, it's 1.66 centimeters. And if we compare the answers, what we got here was also 1.66 to three significant figures.